Insertion sort is a real simple idea. We'll run a loop from second element onwards and we'll store each element one by one in this box, and then we'll check that the element which is stored inside this box is greater than the previous element or not. If the element in check is found greater than the previous element, then it will be left as it is and we'll move on to the next one. The next one also will repeat the same. We'll store it inside the box and we'll check if it is greater than the previous element, right? If it is found greater, we'll move on. Now here we have an element which is smaller than the previous element. That means this element is not in order, right? So we need to put this element in a right place. How it will be done? It will be kicked out from its original place. Meanwhile, it will stay here inside the box and it will stay here, and the rest of the elements will fill this gap by moving towards the right one by one. So it will look like this when the movement is done. And once the movement is over, once all the elements are shifted to right hand side, the element which was not in place, which is temporarily stored here, will be moved back to its original place. So after the movement is over and after the misplaced element found its right place, this iteration which was stuck here because of this element will move to the next element to check whether the rest of the elements are misplaced or not. So it will move to 66. 66 will move to this box, and from here it will be compared whether it is greater than its previous element or not. Yes, it is greater. So it will again be emptied, and the loop will move to the next element, 71, which will again be stored in this box, and it will be checked whether it is greater than the previous element. Yes, it is greater. So again it will be emptied, and the next element is 31, which will be stored here, and it will be compared whether it is greater than the previous element. No, it is not. So it will be kicked out from this place, and all the elements will shift to the right hand side to fill this gap. Once all the shifting is done, 31 will move to its right place. Now all the elements are sorted. So what is worth observing here is two kinds of loop will run here. One will check whether the element is misplaced or not, or whether they are in the right order. And once we have found the misplaced element, a second loop will run, which will shift the elements till we find the right place for the misplaced one. So two loops will run here, which in worst case will give a time complexity of O of n square and space complexity of O of 1, because we're not really using an extra array or storage to shift the elements, right? I hope I was able to explain this well. If you have any suggestions or doubts, please write in the comment section. I'll explain insertion sort in more detail when I'll implement this in Python and C, for which you can check out further videos. And subscribe to this channel for more videos on data structures and algorithms.